And so this talk is about something that you may not be familiar with. It's called learning sciences. The learning sciences is a subject that studies the methodology and the theories of the learning process of humans. And there's a concept in the learning science that is called learn by teaching. The idea is that not only students can learn from teachers, but teachers can also learn by teaching other students. As LLM are getting stronger and exhibit some human-like behaviors, we want to ask the question if LLM also present the capabilities of learn by teaching. If the answer is yes, then we may utilize this technique to improve the capability of LLM by letting it to teach other students. Before talking about our methods, let's first make the distinction between two similar but actually different concepts. The first is called learn from teachers, and our goal is to improve the performance of the students. A typical example is knowledge distillation, where we want to transfer the knowledge from a stronger teacher to a weak student. And the teacher can also be smaller than the student, and this is called the weak to strong generalization. This is because we can improve the performance of the strongest students only using the supervision of a weak teacher. And in our paper, we take a look at the reverse direction. That is, we want to improve the performance of the teacher. When the teacher is stronger than the students, this is actually weak to strong generalization. This is because we can improve the performance of the stronger teacher only using the supervision of a weak student. And when the teacher is smaller than student, this is knowledge transferring, because we are transferring the knowledge from this stronger student to the weak teacher. Now you may wonder, how can we learn by teaching? Before answering this question, let's first take a look at how humans learn by teaching. There's a quote from Richard Feynman, who is a theoretical physicist, who once said, "I couldn't reduce it to the freshman level. That means we really don't understand it." From high level, that is, if someone does not fully understand some concept, he cannot transfer this concept to other students. In particular, from the perspective of the learning sciences, they have studied how humans can learn by teaching. We summarize their findings into 3 levels. Firstly, the teacher can observe students' feedback. For example, the teacher can have multiple teaching materials, and these teaching materials can have different qualities. The teacher can use these different teaching materials to teach students. The teaching material that is better than others can more effectively teach students, and the students can then provide some kind of feedback. For example, the student may get a higher score on the exams. The teacher can observe students' feedback and know which teaching material is better than others, and later he can use that teaching material to teach other students. The teacher can also learn from the feedback. For example, the teacher can analyze and reflect on what factors that make up a teaching material that is better than others. Through this analyzation, the teacher can gain a deeper and more structured knowledge of the teaching concepts. And lastly, the teacher can learn from the feedback iteratively. That means the first 2 steps can be repeated in an iterative manner. And in our paper, we want to let LLM to play the role of teachers and the students. And we want to design some pipelines. Each pipeline mapped to one of this level, so that we want to show that the LLM can also learn by teaching in a way similar to humans. And so here comes to our first pipeline. The first pipeline is observe students' feedback. Here we have the step 0, we have inputs that are n teaching problems, and each teaching problem is associated with m exam problems and the corresponding ground truths. So that the teaching problem and exam problems, they are just similar problems to each other. For example, a teaching problem could be asking what is the answer of 1 plus 1, and the exam problem could be asking what is the answer of 2 plus 2. And then for the first step, for each teaching problem, the teacher will generate k teaching answers. Since we use a temperature that is different than 0, the teacher can generate these k teaching answers. They will be of different qualities. Then for the second step, for each teaching problem teaching answer pair, it will be used as the in-context learning example for a student to provide exam answers to the associate exam problems. So the idea is that if this teaching answer is of high quality, then it can more effectively teach the student to answer similar exam problems and therefore achieving high exam scores. And therefore, for each teaching answer, it can receive the score measured by the accuracy of the exam answers. And the last step is that we just select the teaching answer with the highest score to answer the teaching problem. In summary, we want to improve the teacher's performance on the teaching problems. And we first let the teacher to sample like k teaching answers, and we utilize the feedback from the student to determine which teaching answer is better than others. And then we just choose the one with the highest quality to answer the teaching problem. For the setup, we consider two areas. The first is mathematics. The second is code. For mathematics, we use the math capitalized dataset for the teaching problem and the math brackets as the exam problems. Here, the math capitalized and the math brackets, they just provide examples such as what is the answer for is 1 plus 1 and what is the answer of 2 plus 2. And we also use LeetCode topics. On LeetCode website, it groups like coding problems within the same topic. For example, a topic could be dynamic programming. Then all these problems are all related to dynamic programming. And we just choose one as a teaching problem and the remaining as the exam problems. And what could also be used but are not used in our paper and maybe perhaps left as a future study is that perhaps we can split the dataset into training and test speed. And we use the training speed as the exam problems, so we have the ground truth of the exam problems. And we use the test speed as the teaching problems. And we can also use synthetic datasets so that we can easily synthesize like teaching problems and exam problems and the ground truth of the exam problems. And also we can mimic how humans learn by teaching. We can let the teacher itself to directly generate exam problems and exam answers. And this concludes our first pipeline. For the second pipeline, we want to investigate if the teachers can learn from the feedback. We have already collected the scores of different teaching answers from our previous pipeline so that we can construct preference pairs. A winning instance in the preference pair is the one with the higher score, and the losing instance in a pair is the one with the lower score. So the last step, we just fine-tune the teacher with the direct preference optimization, which is a technique can fine-tune the teacher using these preference pairs. You may also see this sum up and sum down when you are using ChatGPT that provides same kind of data for the ChatGPT to fine-tune the model. And this concludes our second pipeline. And for the third pipeline, we want to learn from the feedback iteratively. And so here our inputs are n input problems and n exam problems and the corresponding ground truth. Here the input problems are from the test speed of the dataset, and the exam problems are coming from the training speed of the dataset. And our context for this task is for some binary text classification task. So for the first step, the teacher will generate k teaching problems and teaching answers in a zero-shot manner. We just let the teacher know this is like a binary text classification and you need to zero-shotly generate k teaching problem teaching answers. And this teaching problem teaching answers will be used as the teaching material. Then for each exam problem, the teaching material, that is the k teaching problem teaching answer pair, will be used as the in-context learning examples for a student to provide exam answer. And since we know the ground truth of the exam answers, we can select the incorrect exam answers, and we let the teacher to reflect on the teaching problem teaching answer pair. So a student gets some exam problem wrong, so there is also must be something also wrong with the teaching material itself. So we let the teacher to see what is going wrong with the students to reflect on what is going wrong with the teaching material. And then the teacher can update his own teaching material using the feedback from the students. And we iteratively repeat step 2 to 4 in multiple rounds. And lastly, for each input problem, the k teaching problem teaching answer pair will be used as the in-context learning example for the teacher to provide the input answer. In summary, our goal is to improve the performance of the teacher on the input problems. And we're doing so by letting the teacher to first generate the teaching materials. And the teaching material will be refined and updated iteratively using the feedback from the student. And the feedback is measured by the exam scores. And lastly, the teacher can use his own teaching material to answer the input problems. And for the experimental setups, we use Lear dataset, which contains false statement detections in political media, and the logic fallacy, which classifies the most common type of faulty generalization. And I skipped the results tables, but to conclude, the answer to the question is yes, LLM can learn by teaching for better reasoning. And secondly, we have shown that stronger teachers could improve themselves by teaching other weak models so that we can achieve weak to strong generalization. I think this is quite interesting. Moreover, teaching multiple students could be better than teaching one student or the teacher itself. And this is our main conclusion. Lastly, I want to briefly talk about our future works. And the disclaimer here is that in the paper, we did not claim that we have proposed some novel methods that outperform like some state-of-the-art results. Actually, we put in the title that this is a preliminary study, so that we actually want to gain a deeper understanding of the LLM, but how to further use our understanding to keep improving the LLM are left at future studies. For example, we have made a lot of decision choices, as you may see, that like how to generate teaching materials, how students can learn, and how students can provide feedback. etc. By trying out different choices, we may improve the existing pipeline and further improve the performance of the teacher. Secondly, we can utilize the connections between humans and the LLMs. For example, we can study other learning techniques from the learning science beyond the learn by teaching. There are many learning techniques from this community. Secondly, we can study learning sciences with LLMs. Because the learning sciences, they study humans. And humans, they are not reproducible. They are random, and the experiments are hard to scale. We have already shown that there is a deep connection between humans and LLMs. So can we study the learning science using LLMs as objects? I think that can be also quite cool. And this concludes this talk. Thanks.